Hello, welcome back. In our last example, I'm giving you a practical example of composite function that we encounter in real life. So here, Parkway bought some food items from Costco. The store charges a flat rate of £25 for all delivery. There is also 20% tax on all goods purchased. Suppose taxes by law are not supposed to be charged on delivery services. Which composite function is best for Parkway? So here I'm going to create two functions, a function based on tax and a function based upon only the delivery without tax. So let X represent the amount I'm going to spend. I don't know the amount, so I'm going to use X. £50, £80 is irrelevant. It's just X as the amount that we're going to spend. If that's the case, which means our tax function, which is T of X, is 1.2X, because 20% on tax will be 120%, because from the beginning everything is 100%. If you're going to charge 20% more, that is 120%. 120% in decimal is 1.2 if you think of multiplier method. So 1.2 times the amount that you spend will give you 1.2x. So that's my first function. The second function is total purchase including delivery fee. So here I'll spend X amount and I'm going to pay 25 flat rate for the delivery. So that is my h of x function, tax function, and it's my purchase function, which is h of x. So now let's see. We're going to have t of h of x and h of t of x and see which one will be convenient for Parkway to use. So option 1 is whereby we start with h of x function before the tax function. Let's see what happens. So let's do substitution as we did before. So I'm going to leave the h of x function and I'm going to put it back into this. So I'm going to have t h of x will be equal to t into bracket x plus 25. So I'm now going to focus on the tax function. This is a tax function. Wherever I see x in the tax function, I'm going to substitute x plus 25. So I'm going to have 1.2 into bracket x plus 25. And when I expand the bracket, this is what I have, 1.2x plus 30. So which means that if I start with the purchasing function with delivery before tax, this is what I'm going to have, 1.2x plus 30. Okay, now let's do the reverse. What if I do the second one, which is I start with the tax function, then before I come to the purchasing function. So I'll start with the tax function, which is 1.2x, and I'm going to replace t of x with 1.2x. So I have h into bracket 1.2x. So in the h function, wherever I see x, I'm going to replace it with 1.2x. So h of t of x will now be equals to 1.2x plus 5. Now, if you look at these two, they all have 1.2x, they all have 1.2x. So it's irrelevant how much you spend, this amount will be the same. But there is difference of what add 30 in option 1 and add 25 in option 2. So clearly you could see that option 2, whereby we start with the tax function, is economical because you end up paying less than if you've done option 1, because you're going to have what, £5 less than the latter one. So which means that in this case it is best to start with option 2, where you have the tax function first before you include the delivery, because delivery is not supposed to be taxed. So tax the amount that you spend before you add on delivery. If you start with a function included with the delivery and you put on a tax, you pay more. So this is a typical example of how composite function could be used in real life. I hope you've enjoyed it. Please share with your friends and subscribe to be alerted of more videos. You can also look at the YouTube videos similar to what you have on whatever platform that you are watching. Thanks very much for watching.